Hello dear students, welcome to all of you. You are learning the lesson number first, that is rational and irrational number. Okay, in the previous video or in the first video you learned how to plot the irrational numbers and also natural number, whole number and also integers. Okay, now in this lectures we have to take first point, that is comparison of now when we compare any number or any two number, either first is greater than second, or first is less than second, or first is equal to second. These three possibilities are coming. Same as it is when we compare rational numbers, there are three possibilities: greater than, less than, or is equal to. Okay, so one point is given: if the numerator and denominator of rational number, everyone knows that. Suppose we take one number, that is 5 upon 7. 5 is your numerator and 7 is your denominator. Okay, so if the numerator and denominator of rational number is multiplied by any non-zero number, then the value of rational number does not change. Okay, means suppose you take any number, suppose a upon b. Okay, it is your rational number. Okay, so we have to multiply by, okay, in numerator and denominator by same number. Okay, condition is same number. Okay, k is a same number. Okay, that is k multiplied by a and k multiplied by b. So that value of a upon b and value of right side and left side is as it is, that is same. Okay, but condition is k is not equal to 0. Okay, we take one example. Suppose 5 upon 7. Okay, if you want to multiply by any number, means suppose I want to here multiply by 9. That is 9 multiplied by 5 and 9 multiplied by 7. That value doesn't change. Reason: 9 5s are 45 and 9 7s are 63. I know 5 upon 7 and 45 upon 63 is looking different. But when you again here subtract by 9, that is 9 5s are and 9 7s are, again 5 upon 7 as it is comes. Okay, means when we multiply by same number of numerator and denominator, then value doesn't change, because 9 get again cancel and remain again 5 upon 7. We take suppose 4 upon 3. We multiply by any non-zero number, means you take negative numbers also. That is minus 3 multiplied by 4 and minus 3 multiplied by again 3. That is minus 12 minus 9. Both values are correct or equal, because minus get cancelled, that is 12 upon 9. And when we divide by 12, that is 3 4s are 12 and 3 3s are 9. Again as it is same is there. Okay, so when we multiply by any non-zero number, okay, to the numerator and also denominator, then value of rational number doesn't change. Okay, so by using this property we compare the numbers. Okay, let's see by using solid example. First one is there, compare the numbers. First one 5 upon 4 and 2 upon 3. Okay, so when we compare the rational number, first of all we want denominator same. Okay, first we have to do denominator same. Here denominator is not same, so first one we have to denominator same. So I want here, okay, 4 and 3 LCM is comes 12. Okay, or in short, you multiply by first rational number by 3 and here 4, means interchange, means 4 multiplied by, let's see. So first number is 5 upon 4. Okay, we multiply by numerator and denominator by 3, means this denominator. Okay, that is 5 3s are 15, 4 3s are 12. Equation number 1. Okay, and second rational number we have to multiply by here 4, means 2 multiplied by 4 and 3 multiplied by 4, means in first rational number we have to multiply by second denominator, and for second denominator we multiply by second first denominator. Okay, that is 4 2s are 8, 4 3s are 12. Okay, sorry. Okay, now here denominator is same. Okay, denominator is equal or same. Now we compare numerator. Okay, in numerator 15 and 8. Okay, first one is 15 upon 12 and second one is your 8 upon 12. We compare now numerator. Now whose numerator is greater, then this rational number is greater. So 15 upon 12 and 8 upon 12, denominator is same. So compare 15 and 8. 15 is greater than 8. That is 15 upon 12 is greater than 8 upon 12. 15 upon 12 is nothing but 5 upon 12. 4 is greater than 8 upon 12 means nothing but 2 upon 3. Okay, 5 upon 4 is greater than 2 upon 3. Understand? First we have to same denominator. Okay, denominator first equal and then compare numerator. Next example, minus 7 upon 9 and 4 upon 5. Okay, minus 7 upon 9 and 4 upon 5. Let's see. Here, this one is your negative number. Okay, first rational number is negative and second one is your positive. So there is simply comparison is there. Negative number is always less than positive number. That is, negative number is always less than positive. So that's why minus 7 upon 9 is less than 4 upon 5. There is not necessary how to do that denominator same then compare. Otherwise not necessary. Directly you have to compare. Negative number is less than positive number. That's why minus 7 upon 9 is less than 4 upon 5. Next one, that is C. Minus 7 upon 3 and minus 5 upon 3. Okay. Now here both are negative. That's why we have to go from same steps. Okay. Here numerator denominator is not same. So first we have to do numerator denominator same. That is 7 upon 3 as it is. Minus 7 upon 3 as it is. We multiply by here second denominator. That is 2. That is minus 14 upon 6. Minus 14 upon 6, it is your equation number 1. Same as it is for second irrational number, you have to multiply by 3. That is minus 5 multiply by 3 upon 2 multiply by 3. That is minus 5 3s are minus 50 and 3 2s are 6. Now denominator is same. That is minus 14 upon 6 and minus 15 upon 6. Now in between minus 14 and minus 15, minus 14 is greater. Okay, minus 14 is greater because it is comes in right side. So that is minus 14 upon 6 is greater than minus 15 upon 6. So minus 14 upon 6 is nothing but minus 7 upon 3. That is minus 7 upon 3 is greater than minus 15 upon 6 is nothing but minus 5 upon 2. Okay, minus 7 upon 3 is greater than minus 5 upon 2. Same procedure we have to done here. Okay, here only all 2's are positive, here both are negative. Okay, next one. Okay, these examples are your solved example. Fourth one, that is 3 upon 5 and 6 upon 10. Here denominator is not same. So first we want to denominator same. So 3 upon 5. Okay, so LCM 5 and 10 is 10. So I want here 10. So 3 upon 5 as it is. Okay, from which number multiply by 5 to 2? Okay, which number you have to multiply by 5? Then we answer want 10. So 5 2s are 10. That's why you have to multiply by 2 and 2. That is 3 2s are 6. 5 2s are 10. Okay, that is 3 upon 5 is equal to 6 upon 10. So both values are equal. That is 3 upon 5 is equal to 6 upon 10. Both are equal. Okay. Because 3 upon 5, that when we multiply by numerator and denominator, it comes 6 upon 10 and 6 upon 10 already given. So both values are equal because here this sign is there, is equal to sign is there. Okay. Let's see. There are some rules are there for comparison of rational number. Okay, few rules are given. Let's see. If A upon B and C upon D are two rational numbers, means A upon B, 5 upon 7, any number. C upon D, 9 upon 10, whatever, you have to take any number, are rational numbers such that B and D are positive numbers. Are positive, okay? Means A and C are allowed negative, but B and D are positive numbers. Then first possibility, okay, if A multiply by D, here all are same, A multiply by D, B multiply by C, A multiply by D, B multiply by C, A multiply by D, B multiply by C. Here also these three possibilities. Then okay, then A upon B, C upon D, A upon B, C upon D, and A upon B, C upon D. Let's see. If the value of A upon A multiplied by D means cross multiplication, A and D and B and C. So if A upon A multiplied by D is greater than B multiplied by C, then automatically A upon B is greater than C upon D. How to remember it? See, A is here, so this denominator is greater. That's why A upon B is greater than C upon D. A upon D is equal to, suppose, B upon C. Then here A upon B is equal to C upon D. Okay, and last one, A upon D is less than B. Sorry, A multiplied by D is less than B multiplied by C. Then A upon B is less than C upon D. Okay, clear? C. Okay, so these three properties when we use in some example. Okay, otherwise we have to take first method. In previous this one we have to take now. So let's see. Now by this depend on these 20 parts, we take practice set 1.2. Practice set 1.2. Okay, question is there, compare. Okay, first number is there, -7 and -2. Okay, now in between -7 and -2, a direct comparison is there. Okay, in when numbers are negative, okay, both numbers are negative, so just only compare 2 and 7. 2 is less, that's why -2 and on the number line, let's see, 0, -1, -2, -3 up to -7 is suppose here. Okay, so which number comes in left side in between -7 and -2? -7 comes left side. Okay, left side, so it is smaller. Okay, suppose when we compare any number 1, 2, 3, 1, 2, 3, 4, we compare 2 and 4. 2 comes left side of 4. That's why 2 is less than 4. Okay, when we take 1 and 2, 1 comes left side, so 1 is less than 2. Okay, when we compare two numbers, just think that it is on number line and which number comes left side, then it is less. Okay, so -7 is comes left side, that's why -7 is less than -2. It is direct answer. Second one, 0, -9 upon 5. Okay, negative number is always less than 0. So we write here, or 0 is greater than any negative number. Because on number line, on the left of 0, all negative numbers are come. That's why on the left of 0, that's why 0 is greater. That's why therefore 0 is greater than -9 upon 5. Okay. Third one, 8 upon 7 and 0. Now same like 0 is less than any positive number, or positive number is greater than 0, because on positive side, left side is 0. That's why therefore 8 upon 7 is greater than 0. Okay. Now next one, example number 4, -5 upon 4 and 1 upon 4. Not necessarily you have to compare 4, because first is negative and second one is positive. So negative number is less than positive number. In that one solved example is there like that. So -5 upon 4 is less than 1 upon 4. Okay, 1 upon 4. Next one, fifth one, okay, let's see, fifth one, 40 upon 29 and 141 upon 29. Okay, let's see. Now here both are positive, but denominator is same. So denominator is same, so compare numerator, that is 40 upon 29, and in that 141 upon 29. Denominator is same, so compare numerator, 40 and 149. 141, sorry. So 40 is less than 144. That's why 40 upon 29 is less than 141 upon 29. Next number is there, Let's see. Six one. Okay, minus 17 upon 20 and minus 13 upon 20. Okay, same here. Minus 17 upon 20 and minus 13 upon 20. Denominator is same. When denominator is same, you compare numerator. In numerator, minus 17 and minus 13. So minus 13 is greater than minus 17. That's why minus 17 upon 20 is less than minus 13 upon 20. Okay, next one. 15 upon 12 and 7 upon 16. Okay, 7 upon 16. So first one. There are two methods are there. Okay, first we have to take this one. So first one, 15 upon 12. Okay, there is cross multiplication is great enough for okay, let's see. 12 and 16. There is any LCM is there? Okay, let's see. 15 upon 12. Okay, now same way. So first we do cross multiplication. That is 15 multiplied by 16. Okay, that is that is 240. Okay, and then cross multiplication 12 multiplied by 7, that is 84. Okay, so in between 240 and 84, 240 is greater than 84. Okay, now 240 is, that is 15 multiplied by 16 is greater than 12 multiplied by 7. Therefore, which value comes? 15 is the numerator. That's why 15 upon 12 is greater than 7 upon 16. 15 upon 12 is greater than 7 upon 16. Okay, next one. 81 is there. Minus 25 upon 8 and minus 9 upon 4. Okay, now I want to do denominator is same. So there is not necessary you have to multiply by first number. Only you have to multiply by 2, then we get 8 is there. So minus 9 upon 4, that is equal to minus 9 multiplied by 2 and 4 multiplied by 2, that is minus 9s are 18 and 8. Okay, minus 18 is there. So in between minus 25 upon 8 and minus 18 upon 8, denominator is same. Why we do not do here denominator is same? Because 12 and 16 are greater number. So if you multiply by here 16, 16, then 12, 12. So that's why we do cross multiplication. Means you have to use another method. Okay, we have to use this one is your first method. First we have to take do that denominator is same. So now compare numerator. Minus 25 and minus 18. Minus 25 is less than minus 18. That's why minus 25 upon 8 is less than minus 18 upon 8. Minus 25 upon 8 is as it is. And minus 18 upon 8 is nothing but minus 9 upon 4. Okay, minus 9 upon 4. Now next one, that is 9th one. There are two examples on PDF. That is 12 upon 15 and 3 upon 5. Okay, let's see. Now to take same way, here 15 is there. In 5 table there is 15 is there. That's why we multiply by here first term only. In second irrational number, that is 3 multiplied by and 5 multiplied by. Which number we have to multiply by 5? Then you get 15. Then 3. That's why we multiply by in numerator and denominator by 3. That is 3 3s are 9, 5 3s are 15. So direct comparison is here. 12 upon 15 and 9 upon 15. Denominator is same, so numerator comparison, numerator that is 12 is greater than 9. So 12 upon 5, 15 as it is and is greater than 9 upon 15 is nothing but 3 upon 5. So 12 upon 15 is greater than 3 upon 5. Take last example, that is example number 10. minus 7 upon 11 and minus 3 upon 4. Now we see same is here. Okay, we have to multiply by minus 7 upon 11. Now 11 and 4 are less numbers are there. That's why we multiply by here. Minus 7 multiply by 11 multiply by denominator of second one, that is 4. Minus 7 are minus 28 and 11 4s are 44, sorry. And then in second one we multiply by first denominator, that is minus 3 multiply by 11 and 4 multiply by 11, that is minus 33 upon 44. So compare first these two numbers, that is minus 28 upon 44 and minus 33 upon 44. Minus 28 is greater than minus 33, okay, because minus 28 comes right side, minus 33 comes left side. So therefore minus 28 upon 44 means minus 7 upon 11, okay, is greater than minus 33 upon 44, that is minus 3 upon 4. Okay, that's why this way we have to complete it. Exercise your or practice set 1.2. Okay, now some example afterwards I give homework. Okay, in homework first you have to copy down that theory parts and also solve example as well as this practice set, code practice set. Okay, we solve already. You have to, by using video, you have to write in your notebook. Okay, today we stop here. In next period we take next part. Thank you.